Alrighty, here we go. Day 6. Going to do a little graphing today. Going to use our calculator in a different way. So if you don't have the TI Inspire, some of this you're just going to have to kind of watch and see what's going on. You're not going to be able to do it on your own. I got to remember to put this. If I don't remember to put this up on the website, www.nkinfinity.com. If I don't get this TNS file up online, make sure you let me know. Give me an email. I'll put it up there. My name is, or I'll show you a link on the TI website where you can get it, something like that. My name is Mr. Krause. You can call me Mr. Key for the next 30 minutes or so. So today we're going to talk about graphing the sine function. First trigonometric function that we are going to graph. Let's do a little warm up first. These ones you should be doing on your own. And see what you do, and then we're going to get to the graphing. So pause it for a second, try these on your own, and then come back. All right, should be back now. Quadrantal angles, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. You should know this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees. By now, this stuff ought to be just ringing, true all the time. All right, 30 degrees. Let me get the reference angle. Even though this is 30 degrees, this is 150. This is 210. This is 330. Those are the actual angles. These are just the reference angles. And if you remember correctly, let's go 30 degrees. 30 degrees, we put down which one? That's right, we put down the index finger. Try to give it so you can see this. So that means 3, 1. Square root of 3 over 2 and 1/2. Now that's going to be true for all of these, all three of these. Square root of 3 over 2, 1/2. Square root of 3 over 2, 1/2. Square root of 3 over 2, 1/2. For every single one of these, the only difference is going to be whether or not they're positive or negative. In this quadrant, x is negative. In this quadrant, they're both negative. And in this quadrant, y is negative. All right, let's do one more. 45 degrees. Let me write down what the angle measures are. The angle measures, and that one's 45. This is 135. This is 225. And this is 315. And when it's 45, you put down the middle finger. Middle finger goes down. We got 2 over here, 2 over here, square root of 2 over 2. Square root of 2 over 2. So for every one of these, it's going to be the square root of 2 over 2, the square root of 2 over 2, 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 square root of 2 over 2. Anybody getting tired of me saying that? Square root of 2 over 2. And the only difference, again, once again, are going to be the signs. In this quadrant, x is negative. In this quadrant, both x and y are negative. And down here, y is negative. And then finally, 60-degree angles. Let's go through these. 60-degree angles, this is 120, this is 240, and this is 300. Those should be angles you just all of start to recognize. So when I talk about 60 degrees, I believe I put down the ring finger, right? So I do 60 degrees ring finger. On the left side, I have 1, and on the right side, I have 3. X value, Y value, okay? So 1/2 square root of 3 over 2. So these are all going to be 1/2 square root of 3 over 2. 1/2 square root of 3 over 2. 1/2 square root of 3 over 2. Again, put the signs in. Over here, x is negative. Both are negative in the third quadrant, and only y is negative here. All right, hopefully you did okay on that. All right, so here we go. I haven't done a lot with these yet. But when we're dealing with graphing, we have to be in radian mode. We have to deal with radian. When you're using the graphing calculator, you have to be in radian mode, which is why I have put these all in radian measures. I don't know why I put these on the left, and that's bothersome. So let's see how we do this. The sine of 0. 0, I put down the thumb. None to the right, 0. The sine of 90 or 180, reference angle is 0. Sine of 2 pi, reference angle is 0. And if I go in the backwards direction, these are going to still be zeros. Now, pi over 2 is 90 degrees. If I do 90 degrees, I'm going to put down the pinky. To the left is 4. Square root of 4 is 2. 2 over 2 is, 1. 1. 1. 1. Now, I got to remember which quadrant it's in, because there's only going to be a couple that are positive. In fact, there's only, let's see. This will be positive. 3 pi over 2 is 270. That's going to be negative. Negative pi over 2 is negative, but negative 3 pi over 2 is positive. So all those are positive. And then pi over 4 is really the square root of 2 over 2. Now, if you put this in your calculator, you get 0.7071. So all of these are divided by 4. So they're all going to be 45-degree angle. Now, you got to figure out which quadrant we're in. I don't know why I'm putting all these. I could just put 0.7. All I'm doing is graphing it. All right, so let's see what quadrant it's in. This is quadrant 1 to the 90 degrees. This is quadrant 2 to the 3. Okay, and that's positive. Now we're going to be in all negative. Negative. Quadrant 4, negatives. Up to here. And then this is, so these are all negatives on the bottom, all positive. Okay, so I got it. So, 0, 0. At pi over 2, I'm at 1. At 3 pi at pi, I'm at 0. At 3 pi over 2, I'm at negative 1. And at 2 pi, I'm at 0. Go in the other direction. Negative pi over 2. I'm at negative 1. Then 0. Then positive. So if I just graph those points. Now you'll notice I didn't graph the 45 points. I'll do those in a different color just for fun. At pi over, these are all the 45-degree angles in between each one. So at 45 degrees, it's 0.7. It's right about there. Also 0.7 here. And then these will be negative 0.7s. And then negative 0.7s right about here and here. And then positive points. If I graph those points, that's what I get. Now, it is a smooth curve that goes through these points. It is not, and this is very difficult to do with this pen. Notice they're curves, not straight lines connecting dots. Sine curve will start at 0, will end at 0, and go up and down. There it is. Now, if I wanted to see what that looked like on my graphing calculator, oh shoot, how do I get back to this? I think I can be all right. If I want to see how this is going to look on my graphing calculator, notice I have to be in radian mode, and I just want to graph sine x. So sine x. Now it's going to look kind of funky here because I'm going forever, because it goes forever and ever and ever and ever and ever. Remember, circles, angles just keep going and going and going and going, but it's going to be cyclical. All right, so if I want to make this a little bit better, I'm going to go into menu, zoom. I might just go zoom trig. Ah, there's a nice curve, right? This is what I got. Up, down, and back up. That's exactly what I just graphed over there, except it looks a lot smoother. So what I've graphed here is a function. It definitely is a function. It is a function. Let's talk about the domain and the range. The domain would be from negative 2 pi to 2 pi. And the range would be from, what's the lowest value? Negative 1 to the uppest to the highest value, which would be 1. So there's my domain and range. So let me ask you this question. Is it a function? Sure, it passes the vertical line test, but it doesn't pass the horizontal line test. So what I want to do, at some point I'm going to want, I think I'm going to do this next. Let me take a look at my notes. I want to graph, see if I can graph an inverse. So I know that the inverse is not going to be a function. So in order to graph the inverse and actually kind of make it meaningful, what I'm going to do is I'm only going to graph from here to here, because that's from -1 to 1, and that would be, its inverse would then be a function. See, then it passes the horizontal line test. So I'm only going to graph from -pi/2 to pi/2. So my x values are going to be, well, if I do that, let me come back up here. If I graph from -pi/2 to pi/2, which x values do I want to use? Let me highlight them. Where's -pi/2? There it is. -pi/2, -pi/4, 0, 0. There's 0, 0, pi/4, pi/2. So I'm only going to graph those. But remember, when we have an inverse, we're going to switch the x and y. So 0, 0 is pretty easy. It stays 0, 0. But when y is -1 up there, x is pi/2. So when this is -1, this is pi/2. And then what's the other one? Oh, pi/4. So I got -0.7. We'll just do -0.7 and -pi/4. And then pi/4. So how about 0.7 and pi/4? All I'm doing is switching these. And +1 and pi/2. So let me graph those points. Now notice the x and y scale switched because I knew my y values were now going to have the radian measures and my x values were going to have the integers or real numbers in it. So let's go 0, 0. Now let's go -1. Oh, this should be -pi/2. -1, -pi/2. -0.7 pi/4. 0.7 pi/4. And 1 pi/2. And that is the inverse function of the fine. This can be written like this. Sine, just like we've done before, -1 of x. Or many times or oftentimes you'll also see it written as arcsine. These both mean inverses. So arcsine of x and sine -1 of x, or inverse sine, is another way, are both ways to say the inverse sine function. So let's talk about that sine curve. Now normally when we graph using the calculator, we need to make sure our calculator is in radian mode. That doesn't mean we don't know what's going on. Start at 0, 0. We're going to end at 0, 0 because 0, sine of 0 and sine of 90 degrees are both the same. Now, what is the sine of 90 degrees? The sine of 90 degrees is 1. The sine of 180 degrees is 0. And the sine of 270 is -1. Now, we've talked about this already. We've just graphed it. It's going to look like this. Now, the functions are going to look the same. Either whether I do it with degrees or radians, it's still going to look the same. 0, 0. Pi/2 is just 90 degrees, same thing. 0, 0, -1, and 2 pi. It's still going to look the same. Hills and valleys is what Miss Newman calls it. But you start at 0, end at 0, 0 in the middle, and you go up and down. So let's see. Can you use those two functions that I just drew up there to answer these questions below? Try to get them all on one screen. What is the sine of 90 degrees? 1. What is the sine of 180? 0. What is the sine of 0? 0. Sine of 270? Negative 1. So I was able to use that graph to answer those. Now let's do sine of 3 pi over 2. 3 pi over 2. Oh, negative 1. 2 pi. 0. Pi over 2. 1. And the sine of pi. 0. So it's pretty easy to read right off the graph if I graph it correctly. So let's practice. Determine the sine curve. Using the sine curve to determine the following. For what values of theta... Oh, wait, hold on. Yeah, I knew that. Hold on, I'll be right back. So, well, let's regraph this thing real quick. Remember, we're going to start at 0. We're going to end at 0. We got 0 in the middle. And you got to make sure that it's 0, 180, 360. We're going to go peaks and valleys, hills and valleys, up. That's terrible. Down. So the question says, for which values from 0 to 360? I could ask from 0 to 2 pi. Those would be equivalent. Does sine equal 0? Well, sine equals 0. Remember, that's when the y value equals 0 or when the function is hitting the x-axis. So that's at 3 places. That's at 0, 180, and 360 degrees. Where does it equal 1? Well, it only equals 1 at one place right there at 90 degrees. Yeah, that's one crazy looking thing. And where does it equal negative 1? At 270 degrees. That's it, right? Okay. So what I'm going to ask you to do now is, if you were in class, you would log on to, and create. Now, if you don't have a TI Inspire, kind of just follow along. And let's see if we can just go through this. And we're going to describe the effects on the graph. So what we're going to do is we're going to go over to our TI Inspire. Let me see if I can blow this up a little bit. View, zoom, go 250. I'll keep that off to the side. So we're going to graph and utilize sliders to explore this function. Notice where my A is. I got an A here. BX, C, and D. I don't think we're going to get into C and D today. I hope not. Maybe we will. Yeah, we will a little bit. But let's see what effects changing A, B, C, and D have on it. Okay, first we're just going to adjust at A. So you'll notice I have a slider for A. So A is this number in front, and they want us to change this to 1.5. So we're going to hit up. Oh, there it is, 1.5. Down, up, down, up. Does it make sense that that's a dilation? That's a dilation of, if I change it again, it's getting steeper and steeper and steeper and steeper, and then I go down. So when it's at 1.5, what happens? What's my max point when, oops. My max point when this is 1 is 1. What's my max point when I'm at 1.5? Oh. So how does this affect the graph? It changes the highest point or the maximum to 1.5. Describe how this changes the equation. Well, all that does is it puts a 1.5. It changes the coefficient out front. So we know this is a dilation. We know this is a dilation where we're going to have a new maximum. Now, I want to manipulate it. We're going to go to 3 first. So 3 is just going to change it so that it is much steeper. Now my maximum value is 3. So that doesn't come as any surprise. It's just a dilation. The number in front is going to be a dilation. It's going to get steeper. If I go down to a half, notice what's happening. It's just getting smaller and smaller. Ooh, 1.5. Now I'm at 0.5. Now, zeros is nothing. That's kind of boring. 0 times anything is just 0, so it's just a horizontal line. But let's see what happens when I hit negative. Ooh. Now, that should come as no surprise. The above, when it was above, that was a reflection. It was the regular sine curve. But now this is a reflection. Notice if I change this to sine -2, all it is it's coming down first. my maximum value is still 2. Wait, my minimum value is negative 2. So my maximum value will change from 1 to 2. My minimum value will change from negative 1 to negative 2, but it is just a dilation. But the negative in front, just as we've discussed in many previous units, is just a reflection. So let's see if we can figure this out. Use your knowledge of A to sketch a sine curve with this. Okay, so normally at pi over 2, we are at 1 right here. But because we have a scale factor of 0.5, it's going to come down to a half. So we're going to, as a sine curve, we start at the beginning, start at 0, 0 in the middle, 0 at the end. Halfway between, we're going to go to our maximum. So instead of having a maximum of 1, we're only going to have a maximum of 1/2. It's going to scale it down a little bit. Now, we've got a couple things going here. We got a negative. So sine curves are all the same pretty much. Start at 0, end at 0, 0 in the middle. By the way, this is until you start messing with C. Once you start messing with C, all bets are off. And you'll see in a minute what I'm talking about. The negative means instead of going up first, we're going to come down. Normally it will be at -1, but because it's got the 3, we're going down. And in between here will be up. So we're going to go like this. All right, let's go mess with B a little bit. Slide B. We got a slider for B. So it's B's at 1 right now. Let's see what happens when I slide B up to 1.5. To 1, or actually now it's at 1.5. Now we're going to 2. Now notice what happened. Here's the starting point. Oh, let me change A back to 1. So normally it would go up and back and that. And it stops at, now it finishes one full curve. We call it one full curve when it goes right back, when it gets back to where it starts from. That's one frequency. B is going to be your frequency. So in this case, and frequency stands for, let me change this back to 1. Normally a frequency is up 1, down 1 in 2 pi. Now I use 2 pi because that's a full circle, 360 degrees. So I'm going to go up 1, back down the middle, back down, and back to 2 pi in 360 degrees, or 2 pi. Now, if I change this to 2, notice what happens. That's 1 full curve, 2 full curves. So now I'll finish 2 full curves in 2 pi. Can I go up any higher? And I think I can only go down to 0.25. Now notice what happens at 0.25. Well, let's go at 0.5. Let's do it to 0.5. At 0.5, I only finish the top half of the curve in 2 pi. So I really only finish half of the curve. This is half of the curve, the top half. If I change it to 0.25, I've only finished the first part of the hump in 2 pi. Back to 1 full curve in 2 pi. You'll notice at 1.5, I finish 1 full curve, and then half of another. There, see the other extra half right there? So, changing, if B is 1, how many full cycles? 1 full cycle. CLE. If you have 2, that's 2 full cycles. And this is a half of a cycle. And by a cycle, remember, a cycle is starting at 0, ending at 0, 0 in the middle. 1 full curve, up, down. This has no change when you have 1. When you have 2, it changes the frequency. In the graph, in the number, where is it changing? I didn't even talk about where the graph changes. Look at this. Look at the number over here. Right? See this number? It's going to change. See right here? It's changing. So it's changing the number in front of the x. So the number in front of x changes to 2. In this case, the number in front of x changes to 1/2, so you get 0.5x. So what are these going to look like? 4x. Now, 4x, the 4 being in front means I'm going to finish 4 full cycles of the sine curve in 2 pi. So here's 2 pi. I'm going to end and begin. That means in pi, I'm going to finish 2 full cycles. That means in pi over 2, I'm going to finish 1 full cycle. So somehow, I got to finish 1 full cycle. That means halfway in the middle are always going to be zeros. So let's see. This is going to be a pain in the neck, especially with this one. So I'm going to go up, back down. Oh, I should only be hitting 1, not 2. So up, down, 1. Oops, I got to hit the 1. Shoot. Told you this is a pain. So up, down, and back to 1. Up, down, and back to 1. Now I've finished 2 full cycles. Up, down, 3 full cycles. 4 full curves in 2 pi. This is I'm only going to what? I'm only going to finish a quarter. A quarter. That means I'm a quarter of the way around the circle. That's at 90 degrees. So I'm going to end at 90 degrees. Now at 90 degrees, sine is 1. So I'm going to finish here. I'm going to start here. I'm going to finish there. And all I'm going to do is that. Believe it or not, that's all I'm going to do. I'm only finished because remember, it's quarter, half, 3/4, full. Quarter, half, halfway, 3/4, all the way. I only finished this piece. So that means it's got to stop at a maximum, which was just 1 here. Woo, C is going to be a little freaky. Let's go to the next page. I think we adjust C. All right, so let's adjust C. Right now, C is a 0. Where did they put C? Oh, they put C at the end. Oh, we're not going to put a D in just yet. Oh, good. Oh, good. Okay. Oh, good. We're not. Whoo, I thought we were going to D already. All right, so you should know what's going to happen here, kids. I got a number at the tail end of this thing. What's going to happen if I put a tail number on the tail end of this thing? You know, this should come as no surprise to you that this sucker is moving. Oops. I screwed it up. I used my key. Why is that not changing? Oh, I think my pen messed up this thing. Hold on. Let me get rid of it. No. Sometimes when I use my pen, my calculator dies. So we're going to go to 2-1. We're going to investigate what happens when we move slide C. This should come as no surprise to you. It's not working. I don't know why it's not working, but it's not working. Maybe I could just change it to 1. Not going to let me change the input. That's not good. All right, I don't know why that's not working. Well, let me ask you this. If we add a number to the end of the graph, what do you think changes? Right, that's a shift up or down, vertical shift up or down. So if I put a C at the end, okay, good. If I put a C at the end, that means we're going to go up 2. It's vertically shifting up 2. This one's down 1/2. This one is going to be up 1.5. Now what's going to change? You're just going to add, at the end you're just going to have a +2. At this one we're going to have a -0.5. And this one we're going to add 1.5. So let's see how this looks graphically. So what I'm going to do, and sometimes it's difficult to understand what's going on. So what we're going to do is we're going to draw in a new x-axis. It's going to be called our midline. So in this case, because we're moving down 2 units, we're going to draw this midline is. This is now my new x-axis, and you'll see how this works in a second. This is where we're going to start, because we're going to, normally we would start here, but we're shifting down 2 units, so we'll start here. Normally I would end here, but we're going to shift down 2 units. Normally in the middle I would be right here, but we're going to shift down 2 units. That's why we put this midline in. In between those, our max and mins are our A values. We're going to go up 1 unit, and up 1 unit, and down 1 unit. Like that. But notice, normally my graph would be here. This is the normal sine curve. Notice it all just got shifted down 2 units. This one's going to go up a half a unit. So my new midline, it's called a midline, is going to go right there. So, let me put this in. I'm going to start at 0. I'm going to end at 0. I'm going to be 0 in the middle. My highest value goes up 1 from here. Up 1 from here would be here. Down 1 from here would be here. So this would be my new sine curve. Just shifted up a half a unit. All right, kids, do the best you can with this. Practice it. We'll do a little bit more with it in class, and hopefully you get a little bit of good understanding of what's going on with graphing. All right, catch you on the flip side, kids. Goodbye.